Hey everybody, it's been a while since I updated last. I have no excuses. I've just been busy and haven't gotten around to it. But a lot of things have changed since the last update. One of the biggest ones is I've decided I'm going to use this ESP8266 controller in place of the Arduino. And there's a couple of reasons for that. Most of it is this has Wi-Fi on it, which makes it so much easier to communicate and do stuff with it. One of the others is that I've started using what's called Circuit Python, and this is branched off of MicroPython, which is taken off of Python. And what it is basically you have a small interpreter that runs on that chip and allows you to use Python on it. And this is actually pretty exciting because up until not too long ago, you couldn't do it. I mean, this is all sort of new stuff, and it's really cool to be able to use Python and quickly see things happen. But being able to use Python makes it the development cycle a lot faster because I can just quickly upload a script, I can test it, I can check it, and I'm ready to go. I don't have to compile each time. And one of the big benefits with this one is that means I don't have to hook it up to the computer. I don't have to hit the reset and the GPIO and the blah 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 because these things were just not easy. They just weren't easy to use a lot of times. Adafruit has a newer model of their Huzzah out now, which is much easier. You don't have to go through all the rigmarole of connecting and disconnecting and all that. And it has a li-poly battery charger on it, which once I get this working, I may switch to using that one. But for right now, this is what it's going to be. And what it's doing is this is feeding into this PCA9685 PWM driver. And what that allows me to do is I can take these two wires here, and run them out to an I2C interface. And it'll let me pulse the motor. I can change which wire has signal, which doesn't, which allows me to move the motors and change the directions and all of that. Also, with pulse width modulation, what that means is that every signal has a high and a low. And what this will do is signal high, signal low very, very quickly. And depending on the width of that signal, it'll determine how long that signal is at high and how long is it low. So the faster the pulse width modulation, the more time spent at high, and then I can control the speed, which is going to be a very important thing for moving forward for what I'm doing. But that's about it for the hardware differences. Oh, and I'm using this right now, but this isn't a permanent solution. This is just because it has two motors and it's easy to test with. And it's also because I broke one of my other motors because it's what I do. So there's that. But getting on to the part that really I think is most interesting, and I'm really kind of the most proud of and excited about, is on these MicroPython boards and CircuitPython as well, which is what I'm using here. You can see here it has what's called a web REPL, or maybe it's called something that's spelled the same way but sounds different. I'm not sure exactly how to say it, so if you know, let me know. But basically what it is it gives you a command line interface that can be accessed over the web. And which, when I first saw it, I thought, oh, that's cool. I can access all this stuff over Wi-Fi. I don't have to connect. But what it also means is I can send commands to it somehow. Somehow this is communicating. So I took that and sort of researched into it and found that it's communicating via WebSockets. And it allowed me to make this. And what this is going to be an interface into my motors and my robot, I guess you'd call it. So I can make it move forward, backwards, left, right, and all of that sort of thing. And this is really just sort of a test environment for right now, because ultimately, as I've mentioned before, the goal is to have this run autonomously off of a Raspberry Pi that just tells this control board, sends it a command, says go that way, go this far, go that far, what have you, based on the input it's receiving. But this gives me a way to visually mess with it and figure out if it's working or not. And you be able to change, eventually we'll be able to change the units on it to millimeters, centimeters, inches, whatever. adjust the speeds, and the distance will be the distance that it travels forward and backwards, and then the degrees will be the degrees that it turns. And there's a little bit more to it. And this is going to be where the pictures are going to be for, so from once the camera's attached, so I can see what it's looking at and determine what my next move will be. And these distance and degree fields aren't exactly, I mean, they're working right now, but they're not accurate by any means. Basically what I've done is said, oh, it has, see, I put 30 in here. I'm dividing 30 by 30, and I'm getting 1, so it knows to move for 1 second. That's all it is. It's just time-based, but it's just there so that I can test to see moving the, changing the numbers if that affects anything. And it seems to be working so far. Okay, so I guess all that's left to do is turn this thing on and see what happens. So I'm gonna, first thing right here, I already have it connected, so I'm gonna disconnect, and then I'm gonna reconnect, and you can see connected, waiting for response. I'm gonna turn my power supply on, because it has a timer on it, so when it's not being used, it doesn't do anything. Alright, cross your fingers. Ha, it worked first try. But yeah, see, so it turns left, and then click it again, turns right, and it's a little off. I'm not sure if that's with the treads or just because I know this motor sticks a little more in one direction than another, so it may be that. But you can see it goes 30 and then 30 back, and then if I change that to, let's say, 60, which I haven't done yet, so let's see how this goes. 60, see, it turns a lot more. But you see how it kind of got bogged down there? I think that's what's making it not work exactly right. See, and it came back a little bit more. But yeah, so it can go backwards, and then it can go forwards. And if I go, I'll go forward one more time. There's a small delay in it that I have built in during my testing so that I can actually see each move. That won't be there later. But see, if I change that to 60, and I hit it to come back again, now it comes back further than it did before. And I can set that back to 30, and then go back forward to where I was. And this is all pretty rudimentary right now, but I'm pretty proud of it. I'm pretty proud that I'm able to get it to this point where I'm able to test it. And the next stages are going to be to get the units working and to get this distance to be actually accurate. And I still want to hook up the encoder wheels once I move to the other chassis. As you can see, there's really not anywhere to put it on this one. That way I'll be able to get the distances and the degrees of rotation and stuff a little bit more accurate and able to use. But yeah, so if you have any ideas, anything you think could be easier or better or improved upon, or if you have a question, let me know. Just post a comment in the description or the comment section below, and we'll see if we can't figure it out together. And one thing else I wanted to mention, if you guys haven't checked it out already, and if you're at all interested in electronics, there's the Adafruit Discord server. It's a great resource with a bunch of very helpful people who, honestly, I wouldn't have been able to get this to where it is now if it hadn't been for a good bit of the help that I was getting there. So yeah, if you're interested in that sort of thing, or just want to chat, or if you have questions, pop in there. It's great. And I do want to say thank you to all the people that did help me on that. But yeah, other than that, that's where I am. And that's about it. That's all I have. So y'all get out of here. Have a good day.